Hello everyone, this is Hating Tian. From this video, we are learning 3.4, polar graphs. Okay, let's see the first one. If I have a equation theta is equal to a is a constant number. For example, theta is equal to pi over 3. We know theta is the angle. That means I need to find the angle which is pi over 3. So from here to here is pi over 3. But I don't know what is my radians. So the radius could be 1, could be 2, could be 3, could be 4. Also could be negative numbers. And so if negative number, I'm going to opposite direction. So it also can be a very tiny number like a 0.0001 and any number between the integers. Connect them. So this is a straight line. If you have theta, the angle is equal to a value. So that's a straight line. For example, if theta is equal to, I say pi. So if theta is equal to pi is a horizontal line, goes through the origin. Okay, so how about next one? If I have r times cosine theta is equal to a. So in polar coordinate, we say the point is r comma theta, but in the rectangular coordinate, the xy plane, we have x comma y, and the x is equal to r times cosine theta, and y is equal to r times sine theta. And in this notation, we have r times cosine theta is equal to a. That means my x value is a constant number. Okay, that means is a straight line, because we know that if the x, so this part represents the x value, x is equal to a. For example, r times cosine theta is equal to 4. That means it's a vertical line, because x is equal to 4 is vertical line. If converted to the xy coordinate plane, we have 1, 2, 3, 4. X is equal to 4 is here. It's a vertical line, goes through this point. So every point on this vertical line has the x value 4. Let's see next example. So if I have r times theta is equal to a, that also means y is equal to a. So y is equal to a is a horizontal line. If I say r times sine theta is equal to -3. That means y is equal to -3. So on the rectangular coordinates or xy plane, let's find y is equal to -3. -1, -2, -3 is the point here. It's a horizontal line, which has the y's value -3. So it doesn't matter what is the x value. So the y's value is -3. Okay, let's move on. So now we are learning circles. So if I have a expression r is equal to a, so what is the meaning of r? Radius. So radius is a. It doesn't mention about my theta. So for example, theta so r is equal to 3, for example. And theta is equal to 0. So my point is here. Theta is equal to 30 degrees. So my second point here. And then 45. So I can plot a lot of points. So it doesn't matter what is my theta's value, the angle's value. My r is always 3. We see this is an circle center at origin. And a is the radius. So 2a is the diameter. So the diameter of the circle is 2a. If I have next expression, r is equal to -2 times cosine theta. So what is the shape of this equation? So the previous one is easy. And this one, I want to list a table. So for example, first column is for theta, the angle. Second column is for the r. So when the theta is equal to 0 degree and the r is equal to -2 times cosine theta, or cosine 0 degree, which is -2. So -2. So when the theta is equal to 45 degree, and we have -2 times square root of 2 over 2, which is negative square root of 2. We keep finding more points. For 90 degree, for 90, we have -2 times cosine 90, which is 0. So is 0. So we keep finding, for example, 135, 180 degree. For example, how about 180 degree? We have -2 times cosine 180 degree. So let me think about it. It is -1. -1 times -2 is +2. So here is +2. So we can keep finding more points. So plot the point. So first point is 0 degree and comma -2. So 0 degree is from initial side. I didn't rotate at all. So from here, and then the radius is -2. That means I'm going this direction. So the point is here, opposite direction. And the second point is 45 degree, comma negative square root of 2. So in the middle, so here is the 45 degree. And then I'm going to backward negative square root of 2 unit is about the point here. So it's about the point here. So you can measure that the distance is about 1.414. Okay, so how about next point is 90 degree 0. So 90 degree, this is 90 degree, but 0, that means it's a point at the origin here. We can ignore this helping dash. Okay, so next point is 180 degree. 180 degree is the angle here, and it is 2. So is this point again. So I skipped some points, but if I don't skip any points, we are going to have a circle. Yes, because now we are learning the shape, which is circle. And center is here. What is the diameter? Diameter is 2, because we can count 1, 2. So diameter also it is 2, which is a 2 in front of the cosine theta. And you can tell that if I have the cosine part, that means something related to the x-axis, because we know that from the previous part we say x-axis, the x is equal to r times cosine theta. And if my expression has a cosine part, that means my graph, you see, the graph of my circle will located on the x-axis. Yes, it's on the x-axis. And the in front of the cosine, we have negative sign. That means my graph is located on the negative x-axis. Yes, if it's positive, it's on the positive x direction. We will do the conclusion later. Okay, let's see next one. If I have r is equal to 6 times sine theta, if I keep listing the table theta and the r, I can choose some values for the theta equals 0 degree, 45 degree, and for example, let's say 90 degree, and how about 135 degree? You can keep trying more points. For the r is equal to 6 times sine theta, so sine 0 is 0, and the 6 times sine 45 is 6 times square root of 2 over 2 is 3, square root of 2. And then keep finding, so sine 90 is 0, so 0. And 135, so let me think about, sine 90 is 1. So 6 times 1 is 6. And how about 135? So let me think about is positive square root of 2 over 2, so 3. So 6 times square root of 2 over 2 is 3 square root of 2. Okay, so let's plot the point. First point is 0 degree and 0. It at the origin. We can use red color. So it's my first point. Second point is 45 degree. So where is the 45? So this is a 45. And then 3 times square root of 2. So 3 times square root of 2 is about, what is that? So something more than 5, more than 4. So for example, randomly pick a number 1, 2, 3, 4. 1, 2, 3, 4. So something about here. So for example, and the next point is 90 degrees is 6. 1, 2, 3, 4, 5, 6 is a point here. Next point, negative, positive 135 is, okay, is some point here. So if I connect the points and plot more point to satisfy this, is a circle. Okay, we can do a conclusion from this circle. You see, the expression is 6 times sine theta. If it is a sine theta, that means something about the y-axis or the y. Yes, you see my graph is located on the y part. And 6 sine theta is a positive. They are on the positive y-axis. And what is a diameter? So in front of the sine theta is 2a. This is a formula. R is equal to positive or negative 2a times sine theta. So the diameter is 2a, which is 6. Yes, from the point here to the point here, the diameter is 6. Okay, so we can use the graphing calculator to graph the so these equations. So they are not functions, so they are the shape of the polar coordinates shape. So for example, if I want to graph, I need to change the rectangular to the polar coordinates. How to change? I'm clicking mode. So let's click mode, and then I need to highlight a degree or radian. So if I'm highlighting the degree and then move down, so here is a function, and move to the polar. So click enter, so we are done and we can quit. Next step is click the Y on the first row, first column Y, and then we have the R. So R sub 1 is equal to, so if I want to graph 3, maybe we can graph the one we have practiced, which is 6 times sine theta. So we click 6 and sine. Now let's click xt theta n. So now we have theta, close the parentheses, and then we hit graph. Oh, this is a circle. Even now you see it's like an ellipse, but this is a circle because you see the diameter is 6. I make it even like the ellipse, but this is a circle because diameter from I cannot graph it. So diameter is 6, and also the horizontal diameter is also 6. So this is a circle, but it seems like a ellipse. Okay, so we can graph more R equations. So we can click 3 plus 3 times cosine theta. We graph it. Okay, oh, this is the heart shape. It's like a heart. So later we are learning the heart shape. And later you will see some dimple shape, dimple limaçon. Okay, so let's see the shape of a circle. So if I have r is equal to positive or negative 2a times cosine theta, or r is equal to positive or negative 2a times sine theta, so these all represent a circle. Here the a is positive. So to be specific, r is equal to positive 2a times cosine theta. How to graph it? For example, I have the xy coordinate plane. The polar coordinate plane, and then we should find here we identify it is multiplied by cosine theta. So my graph, my circle is on the x-axis, and in front is positive 2a. So my circle is on the positive x-axis is the circle, and the radius is 2a. How about if I have r is equal to negative 2a times cosine theta, and cosine theta again, that means we have our circle still on the x-axis, and this is negative in front of the cosine. That means my graph or my circle is on the negative axis of the x-axis, and the diameter is 2a. And how about the next case? R is equal to positive 2a times sine theta. Now we say, if it is sine theta, my circle is located on the on the y-axis, and in front of the cosine is positive 2a, so my circle is on the positive x-axis. And one thing I should remind everybody that my circle must have a point go through the origin, which is 0, 0. Okay, how about the next case, which is r is equal to negative 2a times sine theta. So sine theta again, that means my circle is on the y-axis. If it's on the y-axis, I need to decide a positive or negative y-axis. Negative. So negative y-axis is here at the bottom, and diameter is 2a. Here is also 2a. So some of you say, why you don't put negative 2a? Because I'm assuming this is the polar coordinate. So this is 1, 2, 3. So the distance is 2a. Distance of the diameter is not talking about the x value is positive 2a. The x value is negative 2a on the xy plane. Okay, next one. If I give you the graph, can you find the equation? So this one, this is x-axis. This is y-axis. That means r is equal to, so the graph, the circle is on the x-axis. I'm going to have cosine theta, and I have positive or negative 2a times cosine theta, and it is on the positive x-axis. I can remove the plus or minus sign. What is a 2a? Which is my diameter, and 2a is equal to 8. So r is equal to 8 times cosine theta. Okay, let's see next one. We move very fast, right? So r is equal to what? So this is a circle. I need to have positive or negative 2a times cosine theta or sine theta. It all depends on where is my circle. On the y-axis, I'm going to put the sine theta here, and it's on the negative negative y-axis. So I need to put negative in front of 2a. So circle is on the y-axis, so I must have the sine theta. And this on the negative y-axis, we have negative sign in front. Okay, let's decide the 2a. R is equal to 2a is equal to, let's come back. It's disappeared, but it doesn't matter. So we can do this one again. So we say r is equal to positive or negative 2a times sine theta. And then we say is negative because negative y-axis. And next step, I need to find what is my 2a. So 2a is the distance from here to here, is a diameter, which is 2. So r is equal to negative 2 times sine theta. It doesn't matter here is negative 2 because if it's negative 2, that means is put this graph on the rectangular coordinates system. All right, let's see the cardioids or hearts or heart shape. If I have the equation r is equal to a plus or minus a times cosine theta, r is equal to a plus or minus a times sine theta, we're going to have a heart shape. What does a heart shape look like? This is a heart shape, but the cardioids, this heart, so here is not a pointy, so it's a smooth bottom. Okay, so let's see how to graph this one. If I don't know the rules, I only thing I can do is pick some points and find the r's value. So if the theta is 0 degree, we have 3 plus 3 times cosine 0, which is 1. So we have 6. And then we have 3 plus 3 times cosine 30, square root of 3 over 2. And 45 is 3 plus 3 times cosine square root of 2 over 2. And 3 plus 3 times 1/2. And then what is cosine 90 degrees? 0. 3 plus 0. And the 180 degree is 3 plus. So what is 180 degrees? That's negative 1. So we have minus 3, which is 0. And the 270, so cosine 270 is also 0. So we have 3. And then next step, I need to plot all of these points on the polar coordinates. So first one is 0 degree and 6. So this is 0 degree. And where is a 6? So 6 is 1, 2, 3, 4, 5, 6. Is a point here, first point. Second point is, I need to use my calculator to approximate this value. But if, for example, we can use our calculator to graph it. Because this is the polar coordinates, we need to set our calculator to be the polar coordinates. So first, what should I do? I should click mode and then so scroll down, highlight the degree if it is a degree. And then before on your calculator is function, you can move to the polar. So hit enter. And then second, so next step is click y is equal to, click here. And then we input what? What is the equation? It's 3 plus 3 times cosine theta and close parentheses and then graph. So it's a cardioid. So this cardioid, okay, some of you say, so I prefer to list the table and find the point. Yes, let's do the point. Let's find the table. So you click second, you click a graph. This is a table. You can put theta's value. So for example, theta's value, you can put 0 degree. So you give you R. And you can put 30 degree. Maybe I can delete this. Can I delete it? Okay, second graph, this is a table. So move up, delete this. I hit 0, hit enter, put 30 degree, and put 45 degree, and put 60 degree. These are all the value. Okay, keep putting in 90 degree. And some of you say, my calculator doesn't support me to put the angles. You can click second and the window. So table set window. So you can, so table start from 0. And then you scroll down, you say adding 30 every time. And then scroll down, you can say input, independent. So you say ask. Because if you say auto, it will fill auto by itself. If I highlight auto, and let's see, second graph, that's a table. So it will fill the table by itself from the 0 or negative number, and then 30, 60, 90, it gives you the R's value. If I select ask, second window, I select ask, so second graph, it will ask you the angle you picked. So for example, they will ask you, you can input 0, you can input 30, you can input 45, and they keep giving you the R's number. You can start to graph it. Okay, so let's see the graph. We call this cardioid. Okay, so for example, if I don't want to use the table, that's time consuming. On your exam, also, I won't let you to use the calculator to graph. And if I have the equation, how to graph it? So I can do this. First, I will go back to check my equation. So R is equal to 3 times 3 plus cosine theta. So this is cosine theta, and we are not having a circles because circle doesn't have the circle doesn't have this 3 in front. We only have the 2a times cosine theta, doesn't have a 3. So if you have the a plus a cosine theta, this must be the heart shape or cardioids. And this is the cosine theta. That means, I shouldn't use this. Okay, let's stop. Okay, let's continue. We learned that from the calculator, I can decide the shape. I can graph it. 1, 2, 3. It's a shape. It's a heart shape, and it's located on the positive x-axis. And so these the very important points, they are here. And here is 3, here is 3. If I don't have a calculator, and on our exam or the homework, my teacher doesn't allow me to use the calculator, how can I graph this equation without a calculator? First, I need to identify what is the shape of the equation. This is a cardioid because we have a plus a times cosine theta. For the circle, is R is equal to positive negative 2a times, for example, cosine theta. It doesn't have a 3 part. That means this is a cardioid or the heart shape. And if I have the cosine, positive cosine, the circle is located on the positive x direction. Now, it is a heart shape, so I need to have the heart shape. So I can make a sketch. This is my heart shape. And then the key points here. This one, and this one. This one from the center to the point here is A, which is 3. From the bottom point is also A. And this point is 2A, which is 6. You can use 6 or 2A. Okay. Let's see, next one. If I have R is equal to 2 minus 2 sine theta, you can list a table and find the points, some key points. You don't have to list a table. Excuse me. And later I will do a conclusion, how to find the shape without the calculator or this table. So first, when the theta is equal to 0, 2 minus 2 times 0, which is 2. And then 90 degree, 2 minus 2 times sine 90 is minus 2, which is 0, and the 180, so sine 180 is 0, we have 2, and 270, so is negative 1, so 2 plus 2, which is 4. So these key points, they are 0, comma 2, and 90, comma 0, and 180 degree, comma 2, and 270 is 1, 2, 3, 4 is here. We have these points, but these points are not good enough. We can use our calculator, plug in the equation in the y equals something. So plug in our equation here, and maybe we plug it in here. So the equation is 2 minus 2 times sine theta. So we can graph. Okay, we can delete the first one. So yes, it's a heart shape. And I will not ask you to copy it. I want to verify it's a heart shape like this. If I don't have a calculator, also my teacher doesn't allow me to use a calculator. How to graph it? First, I would need to decide this is a heart shape. Yes, it is a minus a times sine theta. And if I have the sine theta, my heart is located on the y-axis. And in front of the sine theta, what do we have? Negative sign. That means my heart will be located on the negative y-axis. So I'm going to have my heart like this, cardioid like this. And the important key points, here is 2, here is 2, here is 2 times 2, which is 4. Yes, it's the same shape like the calculators. Okay, let's do the conclusion. If I have the cardioid and we have r is equal to a plus a times cosine theta, so now we choose that a is positive, and we can make a sketch. This is xy plane. Polar coordinate plane. So this is cosine theta. So cosine theta, my heart shape will be on the x-axis, and for the x-axis, in front of the cosine is positive. So we have the heart shape on the positive x-axis. So main part of my heart is on the positive x-axis. And here is A, here is A, here is 2A. And R is equal to A minus A times cosine theta. So we're having my graph located on the x-axis, but now the main part is on the negative side because in front we have negative sign in front of the cosine. Okay, the key points, here is A, here is A, here is 2A. And how about if I have R is equal to A plus A times sine theta? So my graph will be on the y-axis because the sine theta, and in front of the sine is positive. So most part of my heart is on the positive y-axis. And this point is A, this here is A, here is 2A. Okay, how about R is equal to A minus A times sine theta. So x, polar coordinate plane. So this is a sine theta, and also this is a heart shape or cardioid shape. So its sine is on the y-axis. In front of the sine is negative, so it's on the negative y-axis. So I'm going to have a heart like this. So the key point here is A, and here is A, here is 2A. Okay, let's see next example. What equation would make the graph? So give you the graph and ask you the equation. This one is cardioid. Cardioid is R is equal to A plus or minus A times sine or cosine theta. So this is a sine and cosine on the y-axis. So this is a sine theta, and is positive or negative. So on the main part, main part of my heart is on the positive x direction. Let's remove the negative sign. We have positive plus. What is the A? So A is the value here, 3. And this is 2A, 6. Yes, good job. R is equal to 3 plus 3 sine theta.